One of the challenges when TCP/IP was first created was that there was no mechanism for automatically assigning IP addresses. And we eventually came up with some other ideas on how to do it, things like BootP, which is now called DHCP. But even then, it required that you had a DHCP server to be able to hand out these addresses. So what about being able to automatically assign an IP address to a computer even when a DHCP server doesn't exist? And the idea that we came up with was something called automatic private IP addressing, and you'll see this abbreviated as APIPA. This automatic method creates something called a link local address. A link local IP address is one that can be used on our local subnet, but it is not an address that a router will send out to another subnet. So we can't route, we can't use the internet, we can't do anything outside of our local subnet, but anybody else who's on our local network would be automatically assigned their own IP address, and we would be able to communicate with them. If we look at the block that's been assigned, the IETF is reserved 169.254.1.0 through 169.254.254.255. Those last 256 addresses are reserved. So you'll notice there's not a 255.255. We have a whole subnet or a whole section of IP addresses that are reserved. But still, there's a very, very large block here we should be able to take advantage of. And the idea would be that we could plug people into their own switch, just a bunch of workstations. When they start up, their computer would automatically assign an IP address to everybody who plugs in, and each one of those computers would be able to communicate with each other. This is automatically assigned, and one of the first things that will happen is the workstation will pick an address out of this range, and then we'll send an ARP out to the network asking if anybody else happens to already own that particular IP address. And if we receive a response back, we know that we need to pick a different one. If we do not receive a response back, then your computer chooses that particular IP address as its own. So one of the things we can do is we can look to see the IP address on our computer, and if it happens to be between 169.254.1.0 through 169.254.254.255, we can say, wait a second, this machine did not receive an IP address via our DHCP server like we were expecting. It was instead assigned an APIPA address, and we need to understand now why this computer was not able to talk properly to our DHCP server. Here's an example of this. I've turned off the communication between my workstation and my DHCP server, and I was assigned an address right here. You can see an auto configuration IPv4 address, and my address was 169.254.228.109. You'll notice the subnet mask is 255.255.0.0. So we've got plenty of addresses that we're able to use in this particular subnet. So just by having this auto configuration built into the operating system, built into the automatic assigning of IP addresses, we know that we could plug this device in just on a local switch with a bunch of other computers, and without having to do anything to IP addressing or to do anything to the IP stack of the computer, it would automatically start up and all of those machines would be able to talk to each other without any type of problem.